Hello, my name is Ben Crabb. I do technical sales and support here at Apogee Instruments. I'm here to talk to you about a changeover that Apogee is implementing with respect to our original quantum sensors, or PAR sensors. These are our economical model of PAR sensors we've sold for many years. They're the little black-headed sensor, and in any way, our component supplier for the diodes on those has stopped producing the diodes, so we've done some research and found a suitable replacement that'll keep the cost and performance, the cost the same and the performance essentially the same. A couple changes I'll go over. And so that's what this brief little set of slides is about. Okay, and so our original quantum sensors we call there are 100 through 400 SQ series. SQ is sensor quantum, and then 100 through 400 are the model numbers. And so these new ones will have an X on the model number. So instead of SQ110, it'll be SQ100X. But I'll go over some of those details. All right, so this change is going to happen June 1st, 2021. We'll begin selling, all the new ones will be this X version, the new original or the X version of the PAR sensors, the original quantum sensors. June 1st, 2021. There's a little picture of the black-headed PAR sensor and the MQ200 metered version, just for reference. Okay, this is a list of the model numbers that are affected, the SQ sensors and the MQ meters. If you want, you can freeze the screen and study the numbers, but like I said, it's the 100 through 400. I guess we left the 400s off, but the 420 is our USB version of this, and 421 is the SDI-12 version of this. Those will also be going away and replaced with these X versions. Okay, changes. There's a different spectral response. Here is a graphical depiction of the change in the spectral response. The old SQ110 are our original quantum sensors in the gray. It's kind of light gray, but you can see that it's a pretty decent approximation of the defined PAR range of wavelengths, 400 to 700 nanometers, indicated by that black dashed line. The 100X version, this new updated version, is the green spectral response. And you can see it generally covers the same area, but like the 110 or the original, it drops off a little in the red. It does a little better job of picking up the blue, and it picks up a little bit into the UVA, but regardless, it can be nicely calibrated to be read accurately under broad spectrum lights. It's going to be calibrated to sunlight, and you can apply correction factors if you're using it under electric lights and you deem it necessary. So that's bullet point 2 here under changes, sun calibrated only, no more electric calibrated models. The new calibration factor for the unamplified sensor, so just the base model doesn't need input power, just generates a little voltage signal on its own. The calibration factor on that is changing from 5 micromoles per meter squared per second to per millivolt to 10. So a calibration factor of 5 to 10. The new one has 10 micromoles per meter squared per second per millivolt of signal from the sensor. So that just applies to the unamplified model SQ100X, and that's the microcache compatible model if you wanted to use our little Bluetooth logging device. So if you're using the old ones, SQ110 and 120, that's the sun and electric calibrated original quantums, and you need a replacement sensor. This SQ100X is a fine option. Just be aware you got to change your calibration factor in your program or in your logger script or whatever data processing you're doing from 5 to 10. Okay, and new model numbers, like I mentioned, the new ones will have an X, SQ100X, SQ200X, or maybe 212X. We'll get it all ironed out, but they will have an X on them. Unchanged kind of hides down here in the corner, but appearance, size, and price are unchanged. They'll look the same. The size of them will be the same. The unamplified version is still going to be the small sensor head. The amplifieds are a little bit wider diameter, but anyway, they match their analogous model of our current original lineup. And the price will be the same. So no change there. These are going to be calibrated only to sun, no electric calibration to keep things simple. But if you are going to use them under different electric lights, you might need to account for spectral errors. This is especially relevant for LEDs because LEDs emit their radiation in narrow wavelength ranges. So, for example, a red LED will emit almost all its radiation out here, like maybe 650 nanometers, where the SQ110, the SQ100X just doesn't do a very good job. And actually the 110 didn't do a great job on that either. So a similar dynamic is at play. There are spectral errors to consider on these economical quantum sensors under electric lights. For sunlight, they're going to be spot on, calibrated well. Under electric lights, there are some errors to consider. And here's a summary graph showing some errors for some commonly used light sources. I'll start over here 2/3 of the way through with a 0 error under full sun. So they're calibrated to sunlight, so it makes sense there's not going to be error on the signal in sunlight. Solar spectrum is what it's calibrated to. Similarly, under these broad spectrum light sources like high pressure sodium and warm white LEDs, we have pretty minimal errors, around 2% error. So that's within its plus or minus 5% calibration accuracy specification we sell these with. I wouldn't even bother trying to make a correction factor for a 2% error. When you use an electric light source that is not broad spectrum but is a narrower spectrum LED, you can have more substantial errors. So for example, here's the big one, red LED, the sensor is going to read approximately 65% low under a red LED. That would emit most of its wavelength in a region where the sensor just isn't that sensitive. So be aware of that. This would not be a great choice to measure PPFD under a red LED. You should get one of our other higher end PAR sensors for that. Here's some errors under other ones. So blue LED, it performs a little better, but it's probably going to read about 15% high. Actinic T5, this is a shorter wavelength, blue or violet type of light. T5 cool white fluorescent, going to read a little bit high. Blue T5 cool white fluorescent, also a little bit high. And that's because it does a pretty nice job of weighting, or maybe it overweights the blue wavelengths a little bit. And then similarly, high, reading a little bit high under white T5s, metal halide lights, and under plant canopy. The plants absorb a lot of the red light, and anyway, when it's under the plant canopy, it tends to read high. So there's a summary of the spectral errors you're likely to see under some common light sources, 8 or 10 of them. We'll have additional spectral errors available on our website. We have a table at this URL. You can navigate to through our support and then quantum sensor support and helpful articles and links. It's a top link there, and it's a table that's full of handy correction factors if you are concerned about trying to do approximate corrections for these 10 or 20% errors. Again, we have higher end PAR sensors that would be a better choice if you're measuring under, especially under LEDs, but electric lights in general, you do well to consider the 500 or 600 series quantum sensors that we have. Okay, a couple last notes. This is the last slide for our new 100X series sensors. Excellent cosine correction, like all the Apogee light sensors. I think the cosine correction on these might be even a little bit improved over the current version. There are economical, lower cost PAR sensor that is calibrated to sunlight, so they're great for weather stations, fully weatherproof and waterproof. People use these. You can use these for PAR measurements underwater. The underwater correction factor is 1.15, so the sensor will be a little bit low, so you got to multiply the signal by 1.15 to get an accurate signal underwater. You can read about that on our website. Underwater PAR measurements is a name of a link if you want to read about it. So these are a drop-in replacement for Apogee original quantum sensors in most applications, like I've said, for outdoor and sunlight use. The same calibration factor applies for all of the amplified models, the digital models. The calibration factor is already programmed on. But if you're using that unamplified base model, the 110 or 120, Those had a calibration factor of 5. This new one has a calibration factor of 10, so be aware of that if you're using the base model. And then, yep, these last points are what I just said. Calibration factor of 10 on the new base model, and spectral errors can occur, which is what the previous slide was about. So for under electric lights, slightly larger font down here, we say the SQ500 or the SQ610, which is our new extended PAR or EPAR sensor, do a great job under any kind of light, sunlight, electric light, combination of any radiation source. It'll give you a good measurement of PPFD or this new definition of extended PAR that is emerging. Okay, that's that's the overview of the 100X, 100 through 400X original quantum sensor update. So that'll be taking place June 1st. New sensors being sold after that date will be the X version, and we'll retain some of the old version in stock for warranty replacements or repairs as necessary. But June 1st, this change will be taking place. And that's that for now. Thanks for watching. Have a nice day. Bye-bye.